Celebrity being a very loose term in this one.
No, it's not just from yeah, that's right.
Not quite. Look at that. So that's a few years ago now.
I like this.
I know we're going to be popular. This whole thing is fake, by the way. I was sitting in the room with a blank tablet just pretending to do stuff on it. The system did work, but it needed like a pretty decent network connection, so there was no way it was going to work over 3G. What's that? Well, I don't know, maybe it would have. We never actually tested it. She only tested it with people in 2 rooms, like.
You know, creating the idea so then if someone else then discovers it and is able to make it.
Yep. That goes against the spirit of research. So yeah, I can talk to you at length about how research and patenting fall together in an academic context.
What is it?
But yes, theoretically she could have.
Well, otherwise people might take it anyway. And then
Yeah. Yes.
Wait, what?
I
missed that. What?
It's like fun when people say, oh yeah, I can't tell my business idea.
Yeah, it's. I mean, it's 2 different schools of thought. Like academics are all about, should be all about making the world a better place. So ideas are free, and that I come up with an idea, and you might improve on it, and you might improve on it, and then you have the commercial aspect where we want to protect our IP because that's where the value of a company comes from, and they're often sort of at heads with each other. But yeah, that's something that I go through on a daily basis with my job. So. I mean, that's a topic for another time. Anyway, back to processing. So hopefully that little video might have spurred your imagination for some of the things, although maybe not, I don't know. But yeah, so just to finish off what we're talking about processing. So processing, as I mentioned, is cross-platform. So it is based on Java. So Java is a cross-platform language. And the way that works is Java. So when I write a program in C or one of these lower level languages, it basically gets compiled directly to machine code, which is specific for the machine that it runs on. Java gets compiled to what's known as intermediary language, which is sort of halfway between what humans can understand and what machines can understand. And then you have your Java virtual machine, which is like, well, in the name, virtual machine. It's a machine which runs on a machine. So you have a Java virtual machine which runs on the computer, and that's responsible for taking the intermediate language, so something halfway between human readable and machine readable, and converting it in real time into machine readable code. So basically for Java, or for C, you write some stuff and it compiles and it will run on your Windows machine or your Mac or your Linux machine or whatever. With Java, you write something that compiles to something which then, as long as you have a Java virtual machine running on your device, it will run. So I write something which is sort of halfway translated, and then it runs on top of my Windows Java virtual machine or my Linux Java virtual machine or whatever else. And for that reason, as long as you have a Java virtual machine written for your device, or that will run on your device, you can run theoretically all Java applications, or at least the large subset of them. And Java claim that they run on 3 billion devices worldwide, because even things like DVD players and stuff like that often use Java because it's a, I guess a write once, run everywhere is what they're trying to push. In reality, it's not quite that simple, but that's okay. The Penguin is Linux. Yeah, so it runs on, natively processing run on Linux, Mac, and PC, or Windows PC, because all of those support Java. It also runs on Android, because Android has sort of a weird multi-layer system, but one of the layers is effectively a Java virtual machine. So processing will run on Android without too much trouble. It is possible to get processing to run on iOS, but iOS does not have a Java virtual machine. So there's a lot of extra messing around because you kind of have to compile your program with the Java virtual machine inside it, which blocks it out. So
It's actually, I just downloaded that. It's got it. Processing it.
right. So is it processing itself or is it a pre-built app for processing?
Critical path processing. But
Yeah, so I think it
you
is.
can actually make things in it.
Yeah, so I'd say so it is possible, and there are instructions online how to do it. I think when you compile your app, you basically have to link in the Java virtual machine, and then you get your iOS app that has the Java virtual machine and the processing sample on it, like all wrapped into one application. So it is possible, but it's not as simple as getting it running on Android or any of the desktop platforms. Even Android is a little bit trickier simply because of the nature of getting stuff running on mobile. So there are instructions here which talk about how to install it and various reference things, because obviously mobile devices tend to have things that PCs don't. So they have touch screens, they have gyroscopes, they have cameras, they have all this sort of stuff. So yeah, there is, to get it working on Android, you effectively have to, from processing, go and add a mode, and then you download the Android mode for processing, and then it should be able to build to an APK for you that you can install on your device. But we won't be doing any processing on Android in the course, so if you want to do that, that's cool. We will, however, when we get to Unity, look at how we can deploy Unity, because Unity is quite handy because it can do iOS and Android more or less natively. So Unity makes it super duper easy. Processing, Android is not too bad, iOS is a few more extra steps. Cool, all right. So that is sort of a brief overview of what processing is. We will go back to what processing offers later. But for the meantime, we're going to talk about some programming basics. So just a quick show of hands again, how many people have done effectively no programming in their lives? Okay, so a good amount. So hopefully some of this will be interesting or educational for you. So we talked about the tutorials and reference, and I've re-included the links here because this might be quite useful for you. But we're going to sort of talk about, I guess, some of the theory, and I'll keep flipping back and forward between the slides and processing. Processing while we go through these things to illustrate as well. So the first thing when we talk about programming, the first thing, and arguably one of the most useful things in programming, is the idea of a variable. So if anyone's done things like algebra or calculus or any of those things from math back in the days, it's effectively the same thing. So a variable is a letter or a word or something that we can give a value to. So we see in here these examples. When I say x equals 1, I'm basically saying there is something called x, and I want to give it the value of 1. So then if I go back and say to it, what is the value of x? It will say, well, x is 1. So for an example, unfortunately I can't just straight out write x is 1, that won't work. If I try and run that, it will complain. Because what I need to do is I need to tell processing what type of information I'm going to put in x. And so you see down here, we talk about types, but we'll come back to that in a minute. But I'm going to say that x will only ever hold a whole number. So it can be a negative number, it can be a positive number, it can be 0, but it's only ever going to be a number, and it's only ever going to be a whole number. So it won't be 1.0, blah, blah, blah. So I'm going to call, and in programming, we call that an integer. So a whole number, positive, negative, but a number, and nothing after the decimal place is called an integer. And by saying int x, I'm basically saying x is a variable and it is only ever going to hold integers. So that will, and at the end of every line of processing, because it's of the C language family, we put a semicolon to basically tell the computer that that is the end of a statement, effectively. It's like how when we write stuff, we put a full stop at the end of a sentence, so we know that that is a logical idea. That's, you know, one thing that we can take away and look at that, and hopefully that's a whole comprehensive thought. So what I've done here is I've effectively said there is a variable called x, and it's going to hold an integer, so it's going to hold a whole number. I haven't actually given it a value or anything yet, which is why you can see down here it's got this little orange thing. The value of local variable x is not used because I haven't put anything in it. I've just said there is a variable called x, and I've done nothing with it. So what I can do is I can give it a number. I give it a value, so x equals 1, and now hopefully that little warning will go away. It's actually still there because I haven't done anything. But now we have, basically when I've done this, the computer's put aside a little bit of memory, and it's said this piece of memory is called x, and it is only going to ever hold whole numbers, and in the moment it's got the value of 1 in it. So what I can do if I want to find out what's in that piece of memory, I can just say print, and in brackets I can say x, and that will issue the print command, which will just write something out to the little console down here. And what we're saying is write out to the console what x contains. So if I hit play now, you'll see down here, it will have 1. So we've created a variable called x, which is an integer. We've given it a value of 1, and then we've asked it to print out whatever is in x, and so it's printed out the value of 1. So I can change that to whatever I want, and when I hit play, we'll see x is now 1123 because that's what I've set it to up here. Likewise, I could add 1 to the value of x. So I say let x equal the value of x plus 1. So the value of x is 1123. So we can say let x equal 1123 plus 1. And when I print that out now, we'll see it's 1124.
So what happens if you put anything other than a whole number?
So, good question. So if I try and tell x that I want to have not a whole number, we'll highlight it in red, and if I click on that, it'll say type mismatch, float. So float is any number with something after the decimal place, does not match with int. And likewise, if I try and put something else in there, actually that will work. For reasons that I'm not going to go into. So this way it says a string, which is essentially a series of letters, does not match with int. But I can put in any whole number, so it can be 0, that's fine, it can be -1, it can be +1, it can be some absurdly large number, and it will happily deal with that.
Does the debugger tell you what, like, when you I can't see that part from here,
Right.
but when you put in like an S, it actually say you have to use the type of string?
Yep, so,
That's pretty good.
sorry, I can make everything larger but the debugger, unfortunately. So it says Java lang string does not match with int.
Yeah, so
X space or you should be using that string.
Yeah,
yeah,
so it's basically x needs to be an int in order for this to work. But we'll come back to that. We're gonna jump back and forth a wee bit, unfortunately. But alright, so the next thing we have here is y equals 0.5. So if I try and say, okay, create a variable of y, which is an integer, and give it the value of 0.5, when I click on it, it says type mismatch, the types don't match. Float, which is what anything with something comes after the decimal places, does not match with int. So it's saying, well, you're trying to put a number with a decimal place or a fractional number into an integer. I can't do that because I only store whole numbers. So what I can do instead is I can say, well, actually, let's make y a float, and then it will happily store that. And if I print out y now, it will show me at 0.5.
Could you put an integer number after a float?
Yep. So we have this sort of, I guess, this hierarchy of things. So a floating point number can be any number with or without, I guess, something after the decimal place, because if a number has nothing after the decimal place, it's effectively .0. So if I put in that value here and print it out, we'll see when it comes out, it's 10,000.0. So it's smart enough to know if I give an integer to a float, just add .0 to it because it's effectively the same thing, which is kind of the reason why it doesn't work backwards, because if I said to an int, what's that, 10,000,000.5, it needs to round that to a whole number, but does it round it up or does it round it down? It actually has no way of knowing, so it just says, well, I don't know what to do with this. these two types don't match. But we'll talk about how to work around that later.
Yes.
Yeah.
No, casting, right here. All right, so that's all great. We can deal with numbers. Numbers are fun. But what if we want to deal with something readable? So what if I want to deal with a letter instead of a number? Well, now this is going to get confusing, and I do apologize for that. When we want to have an individual letter, we put it in single quotation marks. So that represents just the letter X on its own. And you notice here that it will say the value of local variable X is, or rather, you notice here we're basically saying this character, just the letter X, go into an integer Z, and it's actually not complaining about that. So the reason for that, and hopefully this doesn't confuse stuff too much, is everything, every letter on your computer, on your keyboard, has what's known as an ASCII value, which just maps letters to numbers. It's not really important to know why that is or anything, but that's the only reason it doesn't complain. But really, if we want to, like if I print out Z now, because Z is an integer, it will tell me 120, because the ASCII value of X is 120. But that's actually not really what I want. I want the letter X, not a numerical number which represents it. So what I can do instead is I can say, well, X is actually a character or a char. And when I print that out, you'll see down here the character X. But you'll notice if I try and put more than one character in here, so I try and put a whole thing, we'll get an invalid character constant, because that's not one letter, it's a series of letters. So if I want to do a series of letters, I have to use what's known as a string. And strings are different from characters in that we use quotation marks rather than a single quote mark. So we use a double rather than a single. And if I print that out now, you'll see hello. Now I've used a terrible naming scheme here where everything is just a letter, but there's no reason variables have to be just a letter. They can be any alphanumeric thing. So I might like to have instead string my greeting equals hello, and then when I print out my greeting, it'll say hello. So the computer doesn't care what name you give the variable, so you might as well give it something that you can understand rather than writing X, Y, whatever, because otherwise it gets very confusing very quickly because you can't remember what X actually stored, whereas my greeting, oh okay, well that's probably got a greeting in it or something. There are some slight restrictions to it, so you can put a number after a variable, but you can't put a number before a variable.
We can use the reserved words, like string.
Yeah, exactly. So we can't have a string called char, for example. So there are certain, basically anything which appears.
Reserved words.
Yeah.
Like these reserved words.
Yeah, so the words that are already in
In the language, yeah. So anything which appears on this web page, you cannot use as a variable name. You cannot have a variable name which starts with a letter, but you can have a variable name which ends with a letter.
No.
Sorry?
Number.
Number, sorry. Yes, I do remember. Yeah, so my greeting 1 is valid. And so you have my greeting 1, my greeting 2, my greeting 3, but 1, my greeting is not valid. Don't ask me why, that's just the way it is. Okay, so variables are effectively point to pieces of memory that we can put information in and we can pull information out from. So we have various types which basically describe what that piece of memory can hold. And we have two types of type. We have what are known as primitive types, and we've seen 3 of these already: integers or ints, floating numbers or floats, and characters or chars. There's another one called a Boolean, which is just a true or false value. And that's all it can hold. So a Boolean can hold the value true or the value false for nothing else. And these are all primitive numbers, primitive data types, and you'll notice they all start with lowercase letters. Now what a primitive type is basically a piece of data, and that's it. There's nothing else to it. So I can change the value of my bool or whatever, I can't really do anything else beyond that. There is also a type of data type called a composite data type. And composite data type is something like a string, and you can tell a composite data type because it has a capital letter at the start of it. And what a composite data type is it basically is multiple primitive data types all joined together, and then it has some things we can do with them. So, for example, a string is effectively just a whole bunch of characters together. So it's the character H and the character E and the character L and the character L and the character O all punched together. But what we can do with composite data types is we have various functions we can run them. So for example, if I go here to composite data types, you can see here a list of primitive data types and a list of composite. So we'll notice string is here, and if I click on string, it pops information. We'll notice that string actually has a bunch of methods. So for example, one of the things I can do with a string is I can ask for its length, and it will tell me the length of the string my greeting, which contains hello, is 5. So it contains 5 characters, 1, 2, 3, 4, 5. We can also get the character at an index, so we could say, what is the character at, index 2. Now in computers we always start counting from 0 because that's just logical. So this will be character 0, this will be character 1, this will be character 2. So when we say character at 2, we should get the letter L back, which we do. We can do stuff like get a substring, we can convert it to lowercase, we can convert it to uppercase. So I could say, for example, to uppercase, and oops. Now when we get hello, it will be in uppercase. So that's composite. The difference between composite and primitive is composite will have methods that we can use on that variable. So the composite, we can find out the length, for example, the lowercase or the uppercase. If we look at the primitives, we don't have any methods. We can't actually do anything other than set the value or get the value. So it has a name and a value, and that's it. So if you're wondering why certain things, like if you go and write string with a lowercase s, you'll notice that it'll say string does not exist because it needs to have an uppercase s, which then means that you can do stupid stuff like call string, and that'll be fine because string with a lowercase s is not a reserved word. So in programming, well, not in every language, but certainly in processing, capitalization matters. So if I have my greeting like this, with lowercase my, capital G, lowercase r, e-e-t-i-n-g, that is different from my greeting with a capital M and a lowercase g, or a capital M and a capital G. As far as the computer is concerned, they are all different variables, even though to us they look the same. So just be careful when you're naming your variables to give them something which is unique and makes sense. Fortunately, at least the compiler is smart enough to say the variable my greeting does not exist, so I can easily go back and say, okay, why does it say this doesn't exist? Oh, I've put a capital M rather than a lowercase m. But in other programming languages, you may not be so lucky, and you might spend ages wondering why my greeting, which looks like that, doesn't work, and the compiler won't be smart enough to tell you that it's because it doesn't exist. You're like, ah. And then finally you realise you've spelt it with a lowercase in one place and an uppercase in another.
It's good practice to stick to a naming convention.
Yeah, so I use a naming convention which is called camel case, which is where the lowercase will always, or the first word always starts with a lowercase letter, and then every additional word starts with an uppercase letter. I don't know who decided that convention, but it's one of the more popular ones, and it's the one that I was taught with. It makes it, you could theoretically do everything in lowercase and that would be just fine. It just makes it a bit harder to read, whereas you could have something like that, my greeting in English, and then my greeting in French. And I can very easily look at these two things and say, oh yeah, greeting in English, greeting in French, whereas if it was all lowercase, it takes a little bit longer to read. So that's kind of why the first letter is not capitalized, I don't know, but that's just how it is. So yeah, it's up to you to choose what you'd like to do. There are various conventions, but I use camel case, so I find that's what works for me. We're not going to get into the level of detail where you guys are going to be penalised for, having weird variable names or naming conventions. It's really more you'll be kicking yourself for it later if you don't adopt something sensible now, because you start writing programs and the bigger they get, the longer they get, the more complicated they get, and then you can't figure out why things aren't working. It's because you started naming everything in lowercase, and then you decided to switch to camel case, and all of a sudden you're like, why is my greeting in English not working anymore? It's because you didn't stick to something the whole way through.
So with process,
Mhm.
can you do the variables you aware
Yes, yep, so that's a good question actually. So certain languages, I believe C is one of them, you have to define all your variables at the very start. Processing, you can put them anywhere you want. So if you're writing this in C, and let's say we have my greeting in English, just changing it. If in C you wrote something like this, it would complain because you need to have all your variables defined at the start, so you have to have my greeting in English, my greeting in French. Processing, you can put them in whatever order you want. As long as you define a variable before you try and use it, processing will be happy with
You
that.
can define it and assign a value at the same time.
Yes, that's correct. So that's actually another good point. We can define variables without a value, and then later on we can give them a value, and that will work just fine as well. It's just we cannot print out the value of that until we've given it something. Fortunately, again, the compiler is smart enough to tell you a lot of these things early on. So in this case, we've told it that there is a variable called my greeting in French, which is a string. We haven't actually gotten around to putting the value bonjour in it yet, and so when I try and compile it, we say the local variable my greeting in French may not have been initialized, so it hasn't been given an initial value to use. But yeah, that's probably getting into a little bit more of the extra experts territory, but good questions.
Just the colour coding too, which is a clue if you haven't done the words right.
Yes, yeah, so it will do syntax highlighting. So if you write the word string and it doesn't change its colour to orange, then you know that you've done something wrong. So every variable name should turn orange when you write it, and every function like print should turn blue when you write it. And things like strings will turn purple. It's kind of hard to see on the screen. It's a lot more obvious on the laptop screen. But yeah, it does color syntax highlighting, which can help you debug problems. But really, the biggest thing to look out for is the squiggly lines that you get, like when you do a spelling mistake in Word or something, and then you can just click on them and read the little message. And hopefully you can understand the message. It is a little bit in geek speak, but hopefully it makes no sense. You can figure out what you've done wrong.
It's actually a really nice compiler.
Yeah, it's gotten better as it's gone on. It used to have, still doesn't have autocomplete.
Oh, okay, well that's kind of shitty.
Yeah.
Yeah. No, autocomplete or nothing.
Yeah.
That's how you get rid of all
Autocomplete
errors. It's
maybe
autocomplete.
make errors.
Yeah. You can use processing the clips and other things as well.
Yeah. I think I'll be writing it like Sublime or Xcode or something, and then just pasting it with that.
Sure. So, for anyone who didn't understand that little conversation, just don't worry about it. It's not important. Alright. Okay, so let's say I have my integer, my age in years, and have my age in years and months. I think that's my age. But anyway, so these are very terribly named things. Terribly named is a terrible example, but hopefully it gets the point across. So we have two variables here, my age in, actually, no, let's just do, for the moment, my age in years and months. So that is 34 years old and 2 months, that weird thing. So this is assuming a 10-month year. We can get around that, that's right. It's not a good example, just one of the So if I print out my age in years and months, it'll tell us it's 34.2. But let's say I have an integer now, and I just want to get my age in years, but I need to get it out of this my age in years and month variable. So you could say, well, let's just make two of them. Let's just say my age in years, give it the same value as my age in years and month. However, we'll get this type mismatch. Float doesn't match with int, because we're trying to stick a floating point number, so something with a value number after the decimal place in something which doesn't hold decimal places. And so it'll say, well, you can't do that because I don't know what to do. So you can say, well, that's actually a real nuisance because I need to do that. So what you can do is you can use a technique which is known as casting. And casting allows us to convert between two incompatible data types by basically just telling the compiler, I don't care that you can't do it anyway. And to cast something, what we do is we put brackets before the variable, and inside the brackets we put what data type we want it to cast to. So in this case, I want to cast my floating point number into an integer. So I'll just put in brackets next to it, integer, and that will say, okay, I'm just going to convert this floating point number into an integer, and hopefully everything will work out and won't end up a massive mess. So my age in years, oops. So yeah, we've looked at the print statement now a few times. I'm just going to point out another one. So there's also the print-ln statement, P-R-I-N-T-L-N, and you can see down here we've got 34.234. If we just put print, what that does, it will actually just keep on writing after the last thing. So what we've actually seen down here is 34.2 plus 34. If I put println, it will put a new line or an enter at the end of the text. So when I write that out, we'll now see 34.2, and then I'll put a new line at the end of it, and then on the next one, it'll put 34 and put a new line at the end of that.
Does it, when you like cast it, does it just round?
Yep, so that's what we're getting to now. So, good question though. So we've got 34.2, and we've converted that to an integer, and it's given us the value of 34, which, you know, conventional human knowledge, if it's 0 to 4, we round down. If it's 5 to 9, we round up. So it certainly seems to have behaved correctly here. It's rounded 34.2 to 34. And so what happens if I was 34.6? Well, conventionally we would assume that that would tell us that my age is 35, but in fact it just does 34. And the reason for that is the method of casting from a floating point number to an integer is just to get rid of everything after the decimal place. So if we want to round, I believe there is a function in here called round, which will take a floating point number and convert it to an integer using standard rounding rules. But casting by default will just delete everything after the decimal place. So it always, if you ever need to cast from one data type to the other, it's probably a good idea to check to see what the rules are regarding that. And sometimes the easiest way is just to throw in a few bits and pieces of data and see what happens. So if I wanted this to act in a way that was sensible, instead of casting it, I'd use the round function, and now it will tell me that the age is 35, not 34. And we'll come back to functions and everything a little bit later, and why they look different to casting and everything. Okay, so does that make sense to everyone? How we can create a variable and give it a data type? We can give it a value, the difference between primitive and composite data types, and how to cast between different data types.
If you put print somewhere, it just prints one line, and if you put print line,
Yeah, it basically puts in, so I guess for another example, if I print hello, and I print, oops, like that, what we'll see is hello, hi, and it's all on the same line. So if I want to put a new line after hello, I just put print ln, which stands for new line, but the letters are backwards. And we have hello and hi on different lines now.
You can use that for blank lines?
Yep, so if I wanted to put some blank lines in, I could just print an empty string, and it'll put an empty string in there. All right, any other questions?
Just a comment from say how you do comments in code, because it's quite important to comment in code.
It is. Yeah, so that's actually probably a good point, because I always start commenting stuff out and no one understands what's happening. Okay, so we've written some code here that I think is pretty easily understandable, but then I've been doing this for a long time, and I want to make sure that other people can understand as well. So what I can do is I can put in comments into my code, which is basically pieces of text that we as humans can read and the compiler will just ignore. So to write a comment, what I can do is I just put two, I can never remember which,
Slash.
forward slash, yes, I can never remember if it's backslash or forward slash, 2 forward slashes in, and then anything I write after that, and you see it's going to see everything I write after that will be a shade of grey rather than black. And that's just, as soon as the compiler sees these two things, it knows everything else on that line to just ignore. So I could say, this variable stores my age in years and months, and if I want to put another one, I can put the dec number before the decimal point is years, the number after the decimal point is months. And when we run that, well, it's not going to do anything because it doesn't have print statements or anything. But it will, yeah, we can basically, and we can put comments in wherever we want. This variable stores my age in just years. We find this by rounding my age in years, months. Cool. So we can do it that way. If we have a really long comment that's going to be multiple lines, we can actually do a forward slash and a star, and then everything I write until a special symbol will be commented. And that special symbol is the opposite of the start. So a slash and star starts a comment, and a star and slash ends a comment, and until then everything in the middle will be commented out. Whereas with this we have to put a thing on each line. It's up to you. I mean, all of these can be done with a star and a slash. I tend to be quite lazy, so I just put in. I tend to keep my comments 2 lines maximum usually, but other people like to put in tons and tons of comments, and so you might see this. Good point actually bringing up comments now, because I do eventually get to them, but one thing you'll often see me do is I might have something like println my age in years and months, and println my age in years. You might often see me do something like, I'm just going to comment that out.
Yeah.
And commenting out code is a really easy way of quickly disabling functionality without having to delete it. So rather than having to delete this whole line of code and then write it out again, if I don't want it to show up, I'm not quite ready to remove it completely from my project, I can just put the comment symbol behind it, and then it will know, as far as the computer knows, that's actually just a message to me, so it won't execute it. And likewise, you can comment out lots of code by using that, and it will just, it's effectively the same thing as the compiler is deleting it.
It's good to have it to go to comment as you go, even if it's just the main sort of sections. Otherwise, you think, I'll go back and do it.
Yeah,
And
so
you get
it's,
lost trying to look for something.
it's so at my company, there's me and one other programmer, and we've been working together for years, and we have very similar styles. So we might throw in the occasional comment if one of us has done something super weird, and you're like, there's no way I'm going to remember this or be able to explain it, you might throw in a comment, but we're generally pretty light on commenting. We had an intern come work with us, fresh out of university, and to this day we still have no idea how anything he did works because he didn't comment anything. His style and everything was so different to how Julian and I work that we just ended up leaving his code and just working around it. So yes, commenting is very important, and not just for work when you work in teams, but you will be surprised at how quickly you improve at programming, and you'll go back to something you wrote 2 months ago, and you'll be like, I have no idea how this works anymore, because the way you think about things changes so dramatically. Even for me, who I've been programming since I was 8 years old, went back to something that I did last year, and I was just almost embarrassed by how bad it was, because the amount that I've learned in the last year is still enough that you look at, what was I thinking when I wrote this? So yeah, commenting is important. Get into the habit early. You will probably find as you go on, your comments become less, like, you won't comment everything. So I would never write something like this in my code, because I'd like to think I could probably look at that and understand what it means. But if there was something I've done which was kind of weird, I would put in a comment, because there's a good chance I'm going to come back to it later and not understand what I was trying to do.
So useful for just separating the different sort of areas of the code. So this bit lives there, this bit lives there.
Yeah, yeah.
If it's not happening.
That's actually another interesting point. So in processing, white space is ignored, as is in a lot of things. So I can do something like int my variable, and then print my variable. And I could have that block of code commented with do something with my variable. And then maybe I want to do something completely unrelated to my variable. There's no reason I can't go do something with a different variable and have all that stuff down like that. And there's no reason to not do that. And in fact, I will tend to separate, if there's a lot of code which is sort of doing different things, I will tend to put minimum of two enters in between it, because it just makes it easier to read. Again, something that our intern that we got did is he abhorred white space. So everything was written one line after the other, which isn't so bad when you've got 3 lines of code, but when you've got 800, it makes it very difficult to try and figure out. You need to change one thing in 800 lines of code, and you literally have to like read through each one, because you can't tell where the logical blocks of code are. And we'll talk about other ways of separating logical blocks of code using functions and methods and stuff later on.
The arrays, we're going to talk about arrays.
We're going to talk about arrays right now.
Oh, great.
So yeah, that was a little distraction. As we can see at the bottom of this page, we're going to talk about arrays now. So variables are very useful and powerful, because we can store values in them, we can change, we can retrieve what's in the values, we can alter what's in the values, we can perform operations on them. However, it becomes quite tedious when we're dealing with a large amount of similar data to have to name them individually. So you can imagine if I was to go through and go int array, what is going on here? Oh, okay. So we were to go int Aretha's age. I'm not going to ask. I'm just going to do everyone the favor of just putting their name. And so on and so forth. You know, for all of you guys, it's going to become quite tedious and having a lot of variable names. And then if I wanted to do something like find the average age of everyone in the class, I'd have to do something like int average age equals age plus age, and so on and so forth. And it becomes quite tedious and quite frustrating. So what I can do instead is I can use what's known as an array. And an array is effectively a collection of data which is all of the same type. So instead of recording each of your guys' age in an individual variable which is named after you guys, if I'm just interested in maybe doing some stats over the thing, finding out the youngest age and the oldest age and the average age, where it doesn't actually matter whose age is whose, I just need a collection of your things, I can use an array to basically record all the things in one variable, and then I can do stuff on that one variable. So instead what we could do is we could create an array of integers. So this is what we do to define an integer. If we want to do an array, we put open and close square brackets after that. And that tells the computer, actually, we're going to have a collection of integers in this variable. And we're going to say ages in MHIT603, give it the variable name. And then we have 2 ways of creating this thing, creating this array. So we can't just, well, we can just leave it like that, but until we tell the computer how many things there's going to be in this array, how many items are going to be in this array, it doesn't know how much space to put aside. So does it need to put a space aside for one number, or does it need to be 2 or 3 or 4 or whatever? So there's two ways of doing that. The first way is we can say create a new int of length, I don't know how many we ended up in this class, 12 was it? And that will basically tell the computer, we're creating an integer array called ages in MHIT603 and set aside enough memory, so saying new basically says set aside some memory for 12 integers. And so that will basically put aside some memory that ages in MHIT603 points to, and there will be enough for 12 different numbers in there. That's good if you know how much space you're going to need, but you don't know what the numbers are. If we do know what the numbers are when we start, we can basically put that number in MHIT603 by just doing open squiggly brackets and then just putting the numbers in. So let's say there's some people in here. So child prodigy in here apparently. And we can put those squiggly numbers in, and that will figure out how many we need. So in this case, it will set aside space for 5 numbers, and it will also put those values in those numbers. So effectively now, we have a piece of memory pointed at by ages in the MHIT603 with 5 numbers stored in it, and I can get those numbers out simply by saying ages in MHIT603, and then using the square brackets again to say what number. So if I want to get the first number, again, remembering when we're programming, we always start from 0. So the first number 0 will return me the first number again. So if I hit print ages in MHIT603 with 0 in the square brackets, it'll be the first one, which is 21. If I want to get the second one, that'll be 1. And if I wanted to get this one here, that'll be 0, 1, 2, 3. The third one will return our child prodigy's age. Cool. So now, if I wanted to, I could add all those things up and divide them, and that would basically be right there. Do you need to jump out and give a glass of water? You've got a lovely shade of red. It's all right. If you have any questions, you can ask me after class. So yeah, I could now go through and get all those ages one by one without needing to know each of your individual names, which is handy because I'm terrible with names. You're all just a bunch of numbers now, and I can get all your ages, add them together, divide them by the number, and find out the average age of people in the class. So go through and find out the earliest ages, the oldest ages, all that sort of stuff. And that is probably a good place to leave it for today. So when we come back next week, we'll look at operators and control statements, which is where we actually start. Particularly when we get to control statements, that's when we start doing useful stuff. So we can actually make the program do stuff rather than just saying, here is some information, tell me the information back that I just told you. Operators allow us to modify that information, and control statements is where we start putting logic in to say, okay, if this happens, then do that, or for all this stuff, do this, or whatever else. But we'll leave it there for today. Does anyone have any questions?
I do have a comment.
Yes.
Try, if anyone's interested, they should try going on to Code Combat. I don't know if you've heard of it.
Not that one specifically. No.
It's Code Combat.
Oh, Combat, right.
Yeah, it's a website, just like the Code Combat, and it'll teach you how to program in Python, Java, whatever. It's really cool. There's like a